Let's see what we have here. So the time factor, I will leave it as it is because it's 1, and the quality is 512, which is a good resolution for the displacement. For the auto depth, I can just make it 200, or I can reduce it to change the pattern of the waves. I choose to reduce it after I just did some tests. It doesn't really affect much, but it shows more interesting pattern for the waves. So this is the only thing I really changed beside the vertical scale, which was 5 there. I will go to 0.43 or 0.5. That's the same almost, which is a small waves, but it just represents something nice, like nice addition to the displacement already caused by ocean forces. For the auto dimension, also again, I can do 450 as we did actually on the wave here. What is the number? What was the number? Yes, 25. So this is also 25. And for the wind speed 5, 2, 2, and everything exactly. And also the seed should be the same number. And the last thing here is choppiness 0.8, like we did there. But I think I will leave it 2 by 4. That's it. These are the numbers which can present really good displacement for the domain itself. And I will press this as always. And now I can start simulating everything. After this, I can simulate the domain. Then after that, we can add these particles. So this step should be happening before the simulation. Just forget to mention that. Next, what we will do is to create one mesh. So if I will go here, the mesh is one of these because we are dealing with Hybrido. I usually prefer this one. We don't need to do operations like eating from the mesh or doing something else. The smoothness is so straightforward. So now I have the mesh. Let's see the numbers. I can just say auto, and these numbers will work fine. But before we judge anything, we can just create the mesh and see with these numbers. Remember, I'm not activating displacement. I'm not activating the thinning, nothing here, no clipping, nothing. So let's just do right mouse button and build. Let's wait a little and see the mesh. Yes, this is it. So let's just go here to view, to show, and uncheck selection highlight. And also let's press 9 on the keyboard to see the mesh. As you can see, without really changing much of the parameters, we have really very interesting presentation for the mesh with all the splashes and everything. It's so nice. Let's put some notes and change according to the notes. Now, what I notice is that we have noise here, which is not a displacement because we didn't activate the displacement. And also we just accepted these numbers, which we can change to enhance the mesh, but I think they are good now already. What I can do is that I can go down to, if you remember, to thinning here, and I can thin the core at least at the beginning. With the default numbers, I can go and build the mesh again, and that will take care of smoothing the mesh. Again, just to mention, what is that number? This number shows that every particle has this number. And basically, if the particle has a number which shows it belongs to the core more than the surface, and if it's in the surface, in the core, basically, it will be smoothed. Some of these particles has value more than 0.4. Some of them are less than 0.4. And if you are more than 0.4, it will be smooth. Look at this. It smooth everything, but it ate the mesh, actually. So we need to decrease this. Actually, I can go 0.8 and try to remesh again. We have them again. Look at this, we still have some areas to cover. So I think we have to reduce this to 0. Let's say 55. But again, what does that mean is that, what do you think this point is here in the tip? This point has a core value, which is very big, means that it will not be included in this one because yes, very big. It will not be smoothed by the core because it doesn't belong to the core. It's belong to the splash. That's why we have to activate the splash and mesh again. So I will activate the splash and I will put some few numbers here. Then I will change them. So I think we can do 0.42 and 0.4 here. And let's mesh everything. Again, we have some good presentation, but it's so smooth, which gonna push me to do something. I will increase this to 0.4 and I will just change the thinning. I don't need a big amount of thinning for the splash. Also for this one, 0.65 is good. But what I can do also, going here, I can deactivate these and I can change the number here to 0.11 as example, and the same here. It's good to keep these two numbers the same. And what I did now, I increased the volume of each sphere here, which is the metasphere for each particle, to cover these gaps we saw before. Because of that, I don't need really much of the core smoothness or the splash smoothness. Let's just try these numbers, then we'll come and activate the smoothness. So right mouse button and build. I think this is nice, but I can get better presentation by going to 0.06 or the same previous values, and I will activate these. And let's see now. Now we have something nice, but look at these dots. To eliminate them, we can go to 0.0. Sorry. Let's go back to the same number, 0.6. And I think this is a good number now because we will add the displacement, and the displacement gonna enhance everything. So actually, I will leave it as it is. And I will go here and activate displacement. And because we have auto edge length, RealFlow will divide this mesh again and again, producing much more faces to meet the level of details in the domain itself. So let's read now. We have 1 million almost of faces on this mesh. Let's remesh again and see how much we have after we activated the displacement. That's very nice. I think we got what we want. We don't need to really modify more. And the reason for that is that our view is really high. So if we look at it, we'll look at it from here. Almost from this height. Let's say this height, which is really high. And the level of details we have is much more than we need for this mesh. Now what we can do is we can try to remesh some frames. I will jump to 20, and in 20 the whale barely having his head above the water, and I will remesh again. So let's display the particles and see where's the mesh compared to the particles, the actual particles. So we can go to the domain itself and display the particles. So as you can see, the displacement is affecting the mesh. So some of the particles are above and down. Because we will not deal with particles here, everything is good. But if we will display the foam particles, I don't have much particles here for the foam, but in later frame we will see them. I will jump to another frame, which is, let's see, 210 to see the particles first, then we will do the meshing. Look at it from here. Now the meshing should give us really interesting value. Let's look at it. So as you can see, the displacement is moving the mesh away from the actual one, the actual particles, even in these areas. And that's why if we will activate here attenuation on splash, we will have something more close to the actual particles. We can try that now, but other than that, I think everything is cool, and it doesn't really make big difference for us with this chaotic movement. But again, let's hide the particles, and let's see without the particles the shape of the mesh. I think it's just really detailed and it gives us what we need. Let's read here. We have 7 millions, almost 300,000 faces. I can trim this mesh from down or sides or everywhere, but I will not do that. What I want to do is to transfer everything into 3D to see, using V-Ray proxy, we can manage this amount of faces, and the rendering is so fast also. So in this case, I will not trim anything, but if I wanna trim things, what I can do is that what I mentioned before. Let's go into this mesh. We will try to do two things together. I will activate this splash attenuation, and also let's display the domain icon, which is, if you remember, it's here. If I will look at it from 2, this is it. It should trim all these things. If I will look down, just remember, because it's projected, the displacement, I have displacement also down, which is a huge amount of faces. So let's go up for the mesh and activate open boundaries and try to remesh again. Now we have the mesh. Let's see what happened. I will hide the domain, and two things to notice. First, we removed the below surface, and the amount of faces decreased to 4,800,000. So we lost actually 3 million faces by just deleting this side. And also we noticed something. We notice these bumpness, and this is what I think artifact from splash attenuation, which I don't like to use. If we display the particles, it didn't really, it did some work here because we don't have any displacement here and they are exactly on the mesh, but it didn't do all its work as it's supposed to do. That's why I don't prefer to use it. I can do one trial and just look at it from this perspective here and see this area, which I think it's so noisy because of that, and see if it will, this area and this area, if that will disappear after we deactivate the attenuation splash. Now we think I think it's just disappeared. So the idea is that this is buggy. I don't want to use it. Maybe I will use the height one, and it will enhance everything, or the speed one. You just can try and see what is good, but without it, without this thing, the displacement is applied even in the splash, as you can see here. There's a difference between the location, but it doesn't affect our scenery here, and we can work without this attenuation. So I will go back here and see everything. Now we are ready to move to 3D and start working on the shading and lighting. But before that, two steps which I want to do. The first thing is that we can stand here in the first frame, and we can go to meshing, and we choose the or select the mesh, and we run the build mesh, this one, sequence, and it will go through all the sequence, creating all the meshes for us. Another thing, remember the foam. If we will display the foam, especially the foam, or both of them, the splash. Let's just make sure that we are loading the splash. So if I will jump just one frame, and I will go one frame back. We have already the mesh. I want to show you how that will affect the foam, because the foam is the main one who's going to be affected by this displacement. So let's go to, for the splash and the splash, dump splash, it's all above the water, so it doesn't matter really. And I can hide them. But for the foam now, a lot of it is covered by the sea, because the sea is jumping up and down because of the displacement. Means, again, I mentioned that before, we can render the foam alone, render the mesh alone, then put the foam above the sea, because we are looking at it from this angle, so it doesn't matter really. But another technique is to select the mesh, and we can go to Hybrido, and we can press this button, and it will create a sequence of foam. Of course, we select the mesh, then control, we select the foam, then we run this. It will create a foam snap, and it will snap all the foam particles, the new created particles, into the surface of this displacement. This is the solution actually, but we will not do that because we don't need it in our situation. Another thing, so I don't need to see the foam. Already the amount of foam is 14 millions. It's just a lot. I will just make sure that I don't load them also. So we have the mesh, and we can create the sequence, which is good. But before we do that, and before even we start simulating anything, again, I mentioned that again, but I want to just make sure that you remember it, is that if I will go to Export Central, before we do any simulation, we have to export things. So for the domain, I don't really care about exporting things. Already they export what it should export. But for the real wave, I don't need it anyway. For the object, I can export every single one of these, especially the whale. But automatically, real flow will export a file. Its name is animation, which basically this is the exact file we exported from 3D to real flow. It's the animated whale with all the surrounding objects. You will get it. So if you will jump here to the folder and go to here, you will see animation. To object, you'll see animation. This is exactly the file we brought from 3D into reflow. It will be produced again because it's just recorded. So you can just import this Now you open 3D and import this as SD file, and you will have the whale and everything with it without the need to use the 3D file. So again, go to export central. What we need to do is to make sure to export as example the mesh. Before I run the mesh generator, I need to press ABC because I want to produce or export all the mesh cache ABC files. Also, I can do that for all the secondary or the white particles by activating this and this and this. Now it's not activated because if you remember, I pushed this button, made it red. Whenever it's red means it's not exporting. Now I made sure that it's exported, and I activate Krakatoa particle file, Krakatoa, and here Krakatoa. What I mean about that, if we will press this, means that I am exporting all the particles into this format. After I do this, and only after I do this, I can run the simulation and create the particles. Also, I do that before creating this mesh. This is what we need to know for now. And I will mention two things before we export everything into 3D application. The first thing I will mention is about the mist. If we want to create the mist, which is clouds, which shows how the drop of waters convert into mist during the impact, we can go to the hybrido and choose the domain. Then we can just press mist. We have the mist now. And the way we can simulate mist is that we need to see where is the domain. Let's move this domain here. And let's resize it in a way which contain everything inside. And also in this dimension. That's it. And let's remember, if you will notice here, we have this cell size, means that it acts like the domain itself. What is the similarity between the two? Actually, both of them are VDB files. So for the domain, because we are creating field here, the domain has a field in addition to the particles. Actually, we create VDB. And if we'll go here to export, and let's see the domain. The domain has a VDB file, which is a volumetric file, which has a lot of description for this field. Actually, we use this to generate all kind of other particles because we know the velocity, we know everything about it, even the acceleration for the fluid field. So that's for the domain. And for the mist, let's see, here's the mist. The mist is produced in one of these two formats. VDB, which is similar totally to the domain. That's why we have to reduce the cell size to a good amount similar to the domain. So we have really good resolution to render the volumetric output in Fume FX or in Phonics FD or even in Houdini or in Maya. We can render this. But F3D is another format for the volume, which we can export also. And we can just render it using a Fume FX or Houdini as example. But in general, VDB is enough. So in the mist, we can go here and reduce this into 0.15 as example. That would be nice. Or 0.12 as the domain. Else, the parameters here are really simple to describe. What I can add also some wind, which can affect the mist and just affect other particles like the splash, especially the splash, dump splash. But for now, I don't want to add it. It's just you can add it if you have certain windy or direction you want the wind to go through and push the particles, Already we introduced the wind in the ocean itself here because the waves are moving according to that. But for the volumetric shape, which is the mist and the splash part dump, they, in addition to this wind, which affect the main body of water, they have wind here in the air, which can affect them because they are cloudy. So let's go through these parameters very fast and see what they mean. So we have solvers, and the solver is fast, and actually fast is really good. It will represent exactly what we need, but we can also choose stable. And if you choose stable, it's heavier, it's slow, but in the same time it's stable more. So if you have some problems in the fast, we can use stable. The diffusion basically just care about the areas between the particles, between the particles, and when we increase this number, it will expand. So the volume or the cloud would expand if we increase this number, the diffuse more. The dissipation basically, if we increase this number, the cloud will vanish faster. It will disappear. And for the strength, if we increase this number, means that we are increasing the density of the cloud. If we decrease it, it will be transparent more. But also we can control this number in the shader itself. But why not just making sure that it has a good value before we start pushing the shader to produce something? So based on that, we define the density of the mist. For the velocity scale, particles in general, the one which produce the mist, contribute their velocity. So this factor shows how much the contribution, and basically it will accelerate the mist volume. And for the radio threshold, the radio goes 1 when the particle is created, and 0 when the particle will die. So mist will be created when this value, the radio value, is bigger than, when the value of the particle is bigger than this value, the one mentioned here. And when we say 1, it's bigger than the birth. So that's what everything here means. I don't need to activate anything except here if you want to visualize the field, and you can simulate and have the mist. Now we will not render or create the mist in this stage. It will be just another volumetric system to care about and render, and course already is so long, I don't know if you will have the time to do that, but in general this is how we create it. And let's make sure that we have this in cache mode. Whenever we produce anything, we just put the particle system in a cache mode. And after you finish, you will have VDB files, which we can import to 3D using Fume FX or PhonixFD. This is the first thing. And the last thing I want to mention is about the meshing. We have the mesh, but it's a sequence of Alembic files, as we saw. So if we want to convert them into one file, we can go to Tools, Stitch, and we can import them all here as I'm doing here. So you can add and go to, I have a sequence of meshes as example here. Press the first one and go to number 300 because we have 300 for the sequence. I already did more. And open. We have them here. Then we can just export them into one mesh. And I did that also to shortcut the time. And this one mesh is 155 gigs. While if we look at every one of them, it's like almost half gig. So it's just gathering them all together. But because 3D cannot import one by one. But let's just make one note. I don't recommend using this. I recommend to export everything as bin file and try to work with it. The idea about Alembic is that it exports the velocity. It's easy to be handled with also V-Ray proxy, as you will see. Other than that, there is a problem with this because if one of the files is almost zero, as example, sometimes you start from zero, you don't have any particles if you don't have initial state. And if you do this thing, which is stitch everything together, that will affect the final result. It's like an average or something. So it will affect the final result. So don't include it if that's the case. Also, we will notice that sometimes gathering all these as one mesh, it will affect the result. Every one of them individually present exactly where the mesh should be. But altogether, if we will jump to some frame, sometimes it doesn't read the position exactly. We will see about that also. But these are the two notes which I wanted to mention. Other than that, we are ready to import everything into 3D application after we do create the mesh.